This is Corey Crowley, and I'm going through my final project in CSCIE 175 for Harvard Extension. And my final project is on Amazon AWS Storage Gateways. I'm going to go ahead and go through a brief overview of the service from Amazon, and then go into my documentation showing my overview of the demo for my final project. So AWS Storage Gateway is a cloud-based service from Amazon that allows your local computers or applications to access cloud-based storage through a local proxy. AWS Storage Gateways can be used in two different ways. They can be used as cached volumes or gateway stored volumes. Each of those have a slightly different purpose. The gateway cached volumes are good for file sharing, collaboration, maybe between two different sites, two different companies. But in this scenario, you're using local solutions for storing files, so you have fast, easy access to the files, but the files are also being cached on volumes inside the Amazon cloud so that other people can share these files with you. The gateway stored volumes are a good solution for offsite backups and disaster recovery. This is a great solution for basically getting up and running again from a site failure or a complete system failure where you lose local data. As I said previously, gateway cached volumes are normally used for corporate file sharing, and the stored volumes are used for backup. In my pilot, I actually played around with both because I was interested in both technologies, but I'm mainly going to focus on cache volumes for corporate file sharing and collaboration to be able to interact with files between different locations or potentially with vendors or business partners. Inside of my demonstration, this is precisely the type of pilot that I ran, the cache gateways, which allowed me to actually connect to iSCSI volumes from different computers and actually collaborate with files as if they were strictly local file shares, but at the same time that I was copying files into what looked like local iSCSI drives. The data was in fact getting duplicated or cached, if you will, at Amazon. So I'll go through a brief overview here and then get more in depth inside of the demo. But it's a pretty straightforward process. You start the gateway activation in the AWS console to tell Amazon that you're about to start the process of setting up a storage gateway. The first step in setting up a storage gateway is downloading a virtual machine from Amazon that's based on a VMware standard. This is the local proxy I talked about that's going to run in your local environment and act as the go-between between what you're doing on your client and effectively what happens on the Amazon cloud solution. So once you download your virtual machine, you're going to go through the process of setting up a couple of SCSI drives that act as your local storage, make some configuration changes to the SCSI controllers, and then you're going to go back to Amazon and finish up the activation of the gateway. Again, I'm going to go in more depth here in a second, just giving a brief overview here. And once you provide some basic information about the VM that you just configured, Amazon's going to go through and ask you to provide some volume information about the storage that's available on that VM that your local clients will be connecting to. After you go through that process, you're going to use a local PC and iSCSI technology to connect to this drive and use it essentially like it's a standard map network drive. Before I get into the demo, I'll briefly go over some of the pros and cons that I learned while going through this pilot. To reiterate, the cache volumes are great for collaboration and backup. It still uses local files for fast access. The stored volumes are a great solution for offsite backups as part of a disaster recovery plan. Having data offsite or having cached offsite volumes can provide a great way for having redundancy in the event of a local system failure. The other advantage to this technology is the more you utilize Amazon's technology and outsource things like this, the more you're putting infrastructure or applications in the hands of highly trained staff that is sometimes better equipped to manage these complex solutions than trying to do it in-house. Some of the cons are general security concerns that most IT departments have with putting corporate assets into the cloud or running applications in the cloud. Sometimes people think that they can do a better job as far as uptime, or they can do a better job of keeping these assets safe. Corporate information protection also comes into play. When there's trade secrets or any type of sensitive information in documents, there's always management concerns with keeping those documents stored anywhere except for on-premise. File access logs. I didn't find a good way to do auditing or tracking of access of files. I'm sure there's third-party utilities out there that can do this, and there's probably some things you can do at the application layer if you abstract the storage from the end user using an application, maybe SharePoint or DFS or something like that, instead of connecting directly through iSCSI. The other thing that would be nice to see is some Active Directory integration for managing the access control list and some of the policies for things like quotas and, again, access control and auditing. It would be nice if those things were native. So now I'm going to dive into my documentation outlining the demo that I did for AWS Storage Gateways in my final project. This is a little redundant in some of the things that I just went over, but a more in-depth overview in how I set up the pilot. So again, the first step was going to my AWS console. And inside of the console, I'm telling AWS that I want to set up another gateway. Inside of here, I'm running a 60-day trial. I think the point in initiating this part is agreeing to a monthly fee in conjunction with the storage fees. I think you have to pay $125 a month per gateway fee, and part of activating this host is agreeing to those terms and conditions. Next, I'm downloading the VM that we spoke about. That's going to be the local proxy, and this VM, again, is a proprietary VMware solution. That's the only hypervisor client that this solution will run in. After downloading the VM, I chose VMware Workstation. This was a little bit of a challenge because all of the demos refer to a product called VMware Client or vSphere Client that I could not locate. After searching for quite a while, I kind of gave up and went with this new VMware Workstation solution, which seemed to work fine, but I had to jump through a few hoops that I'll explain when setting up my SCSI adapters. So I went through the import process. Here you can see that I'm importing the file that I downloaded from Amazon to set up my VM. After importing the file, I went ahead and changed a couple of settings. I didn't have enough RAM to run the default configuration, so I modified the RAM on the server to be 4 gigabytes. Then I added 2 SCSI drives. For this particular pilot, I added 2 15 gig drives, and I plan on using one of these drives for my upload buffer. later on when I configure the rest of my activation for my gateway. Like I said, my version of VMware did not have a GUI for managing the SCSI controller, so I had to manually edit the SCSI adapter settings to allow para-virtualization on the SCSI controllers. I had to modify a couple of files in the VMware config to set the SCSI type to PVISCI. Next, I launched my new gateway VM. Upon launching the gateway VM, it actually gives you the credentials for logging into the virtual machine. I followed the menu settings to get to the Ethernet controller interface that I'm going to use to communicate with Amazon, and I noted the IP address. Next, I went back to Amazon to complete my AWS Storage Gateway configuration, selected that I wanted to do a cached volume. And then I had to enter my IP address here that I noted a couple of screens previous. After entering the IP address, I went through and I selected an AWS region to run this gateway in, and then I selected a name for my gateway. Then after that, the actual gateway is created in AWS, but we have to associate some volumes with the gateway. So I went in and actually associated the volumes that I'm going to use for storage and for upload cache inside of the AWS console. I'm sorry, upload buffer is the nomenclature that they use. After that, I was given the ability to set up some basic alarms for the AWS gateway. I opted not to do that for the sake of this pilot, but in production, I think setting up the buffer alarms would be a good thing to do, and it would be nice if CloudWatch actually included maybe some more advanced alarms beyond basic heartbeat and monitoring buffer. If we could actually look in and get some statistics to see if daily usage was over a certain threshold or something like that. Now that my gateway and volumes are activated, I can actually go to a workstation and try to connect to these volumes. One of the things that I'll mention here is I tried to actually do this from a Macintosh OS X client first. And I ran into quite a few challenges because there's not a native iSCSI initiator for the Macintosh. So I downloaded a couple of different third-party tools that I never actually got to work right. So I actually abandoned the Macintosh client scenario and used a Windows PC for this portion of the pilot. The first thing that I did was make sure that the iSCSI initiator service was configured. It's installed by default, but it's not running, so I turned on that service. Next, I went into Control Panel and actually launched the iSCSI initiator properties, and went in and gave it the IP address for the discovery portal, and went ahead and activated that. Once it was activated, I was then able to actually see the volume show up in my disk administration tools inside a Control Panel. Inside of here is where you can go in and actually treat this like a standard local drive and go in and format it, give it a file system, and actually give it a drive name. The contrast on my next slide isn't very good, but you can see I gave it a drive letter and gave it the name of AWS Storage Gateway, and I drug a new file into this particular drive. What this did at this point, by using Windows Explorer to drag this file in here, this is actually stored in my scenario on the AWS Gateway storage drive, and then it's actually copied into the Amazon cloud storage drive as well, because I'm using cached volumes. If I were using stored volumes, this wouldn't be stored locally at all. I would interact with it the same way through using Windows Explorer, but the file would then reside solely inside of the Amazon cloud storage. So this is a basic overview again of using AWS Storage Gateways. My impression is that it's a great product that I might choose to implement inside of my environment and my workplace. Using it as a raw storage device, I do see some problems there again once we get into information protection and auditing and security. But I see using it as a reliable cloud-based storage for applications is very feasible, and I could see me putting some applications to front end this and maybe use like Documentum, SharePoint, or Alfresco or something like that for document management, and actually have the data stores for those applications reside in Amazon via the AWS Gateway. I think would be a great solution where I get all of the value of the front-end application and then all of the reliability and the benefits of using cloud storage. So again, that's my brief